My name is Johannes Biala. I work at the Institute for Future Environments, which is at the Queensland University of Technology. And I'm working here in a project which looks at greenhouse gas emissions from the manure supply chain. And manure supply chain in this case means really from where the manure is generated and possibly processed down to the end use where the farmers uses it to grow crops. This project covers a range of intensive animal industries, namely the feedlot industry, the pork industry, the egg industry and also the dairy industry. These four industries supported our project along with the federal government. Our project really covers two systems. One is the manure management at the site, and we're looking at minimizing greenhouse gas emissions through composting, and that is windrow composting and aerated composting. And then the second system is the crop growing farming system, where essentially we are doing the same. We are looking whether use of composted manures reduces greenhouse gas emissions compared to using raw manures. At the moment I'm standing on top of a stockpile of feedlot manure on the Darling Downs. Here at this site we primarily focus on measuring and monitoring greenhouse gas emissions because that is the main concern and of interest to the intensive animal industries. With the manual samples we put the lid on and note down the time when exactly we put it on, because then we have to take the samples at 2-minute intervals, and we'll do it for 2 minutes, 4 minutes and 6 minutes. Once the syringe is on, we'll draw the sample up, we adjust it to 20 mils, and then we put it into an evacuated vial. The sign when it pulls in 10 mil is a sign that it has been evacuated. We put in an extra 10 mil, so it's a total of 20 mil in that vial. That is taken to the university laboratory where it's analyzed for methane, nitrous oxide and CO2. So to measure greenhouse gases here on site, we've got two systems. One is in situ, and that means we use a system which takes measurements 8 times per day. It has got chambers which close automatically, and then everything is analyzed here on site. And in addition to that, we also have manual measurements. They are 50 by 50 metal frames, and we put hoods on, and over a 1-hour period we take 2 or 3 measurements, and from that we can see the increase in gases. The lower emission factors means that more nitrogen stays in the ground and less is emitted. Obviously, you as a vegetable grower, for example, you're interested in reducing your input costs or increasing your efficiency, and our main aim is to improve the nitrogen use efficiency, essentially to reduce the input of mineral fertilizer and for you to account of the nutrients, the nitrogen, the phosphorus, the potassium you apply with these organic amendments. And with organic amendments I mean both raw manures and composted manures, and this is what we are trialing down here. So using these organic amendments, farmers can really reduce their mineral fertilizer input, their mineral fertilizer bill, and the challenge for us is really to get that message out, to get tools out to the farmers so they can really integrate that into their fertilization program.